We are living in the golden age of space exploration. What once belonged to science fiction is now being drafted in mission plans, tested in rocket hangars, and coded into navigation software. From robotic scouts to long-term human settlement plans, the dream of setting foot on Mars is no longer a fantasy, it's a strategy. Let's talk about why Mars is the next big leap, and what lies beyond. Mars has always fascinated us. It's our closest planetary cousin, just far enough to be a challenge, but close enough to be reachable. NASA's Artemis program aims to return humans to the moon by the mid-2020 SS. Not just for a lunar victory lap, but as a proving ground for Mars. Why? Because sending humans to Mars isn't just about distance, it's about time, radiation, gravity, and psychology. A round trip to Mars could take over 2 years. That means surviving on limited supplies, dealing with deep space radiation, and living in tight quarters without real-time contact with Earth. Even light takes 4 to 24 minutes to travel between the two planets, depending on where they are in orbit. To solve these, scientists are developing advanced propulsion systems, like nuclear thermal engines, which could cut travel time nearly in half. And once we get there, we can't just plant a flag and go home. We'll need self-sustaining habitats, recycling systems, and food grown in Martian soil or hydroponic farms. Elon Musk's SpaceX wants to colonize Mars using the Starship, a fully reusable rocket designed to carry cargo and eventually people to the Red Planet. NASA, meanwhile, is exploring the MOXIE experiment, which successfully produced oxygen from Martian CO2 in 2021, a baby step toward breathing on Mars. But let's zoom out a little. Mars is just the beginning. With each leap, we develop tech that brings the rest of the solar system within reach. Once Mars is achievable, asteroid mining becomes viable. Then icy moons like Europa and Titan, both potential homes for microbial life, become the next frontier. And let's not forget, every robotic mission we send now is laying the groundwork for future human travel. The Europa Clipper, Dragonfly on Titan, the James Webb Space Telescope, they're all pieces of a grander puzzle. Beyond even the solar system, scientists are contemplating the first interstellar missions. Projects like Breakthrough Starshot aim to send microprobes to Proxima Centauri, our closest neighboring star, at 20% the speed of light. We're talking decades of travel time. But still, it's the first serious attempt to explore beyond our sun. So why are we doing this? Because exploration is in our DNA. Because understanding Mars could teach us how life began. And maybe how to protect our own fragile planet. Because one day, the survival of humanity might depend on our ability to live beyond Earth. And maybe, just maybe, we'll look up at the stars not with longing, but with plans. This is Infinite Narratives, where space isn't the final frontier, it's just the next stop. Subscribe for more stories from the universe.